Probability have some operations that go with it, and the three that we're going to kind of hit in this video and then throughout are the not, and or. Now, just a brief overview. When I say not, that's the complement of an event. And again, we'll talk more about this in a minute. But if we would be finding the probability of blue, right, that would be blue over all the total. We could also then say probability of not blue, and that implies everything that isn't blue, right? So it's not really a hard concept. It's just everything that's not blue. And in normal probability implies multiplication. We're going to use probability tables, so we're not going to get too much into that. But or implies addition, and we will get into that big time. So that's going to be kind of a little bit more intense than the and because of our probability tables, and you'll see all of that as we work through. Okay, so first things first. When you are given a probability table, often you're going to be given the information on the inside, which is here. From that, we can fill in the outside. So to find out the total males, we add across. I have 120 males. I have 80 females, and you'll see those two add up to 200. I have 50 who were promoted, 150 who were not promoted. Again, those add up to 200. So it's always important to fill up your entire table before actually finding some probabilities. Once we have those totals, and then we can find problems. So when you look at this example, what is the probability a police officer selected at random, so we're looking at all of them, is female? Well, I have 80 female police officers out of 200 total. And 80 out of 200 gives me 0.4 or 40%. So your probability is roughly 40%. Number one, what is the probability a police officer selected at random is male? Well, I have 120 males out of 200, which gives me 0.6 or 60%. And you'll notice females plus males is 100% because it's everybody, right? We would call those complements. What's the probability a police officer selected at random was promoted in the last year? Well, here's promoted, so that's 50 out of 200, 0.25 or 25%. Now, if we say not promoted, in this case, you have two ways to do this, okay? In the terms of complement, we know that complements are two events that their probabilities add to 100%, okay? That's what makes them complements. If two probabilities together give you all of your options. So we know 100% is 1. If I take everything I have and I subtract the probability of somebody being promoted, that's the same as being not promoted. And you might be saying, what are you talking about? Well, we found back here on this example that the probability of being promoted was 25%. So if I take 100%, which is 1, minus the 25% of being promoted, that means 75% are not promoted. Okay, so that's the idea of a complement. Now, in terms of this table, because you might say, I can just look at the table. Totally true, and if you can, you probably should. Not promoted is 150 out of 200, which is 0.75 or 75%. The deal is, you don't always have a nice probability table. Sometimes you're given some information, but not all, and you have to use this concept of 1 minus promoted to get not promoted, because promoted and not promoted together equal 100%. Let's get to the word and, where and is both. So we're kind of looking at the intersection. Find the probability of selecting an officer who is a woman, so here's woman, and promoted. Where do they intersect? Right here. So we have 20 over 200, 0.1 or 10%. So when you're looking for and, you're looking for the intersection. Where do they intersect? Number 5. What's the probability of selecting an officer at random who is a man who was promoted? So when they say who was, that's kind of like saying and. Man and promoted. Well, here's the men, here's promoted, 30. So we have 30 over 200, 0.15, 15%. All right, so and when we have probability tables, we're looking for the intersection piece. Now, so okay, with and, you're looking for the intersection when you have a probability table. If you don't have a table, you have basic information, you're going to multiply. But we don't deal with that here in this class. Or is the concept of addition. You're going to add, but you're also going to then subtract the overlap. And when you say, okay, you lost me, that's fine. I'm going to totally show you what I'm talking about here. So, here we're going to talk about the probability of randomly selecting a police officer who is female or promoted. So, here's females. If I add the females plus the promoted, you can see that the overlap is here. That number is talked twice. Because if I find the probability of, wait, let me get my colors right here. Probability of a female, that's 80 over 200. Plus the probability of being promoted. Well, promoted is 50 over 200. But you notice that I counted this number twice, both as part female and part promoted. So I talk about subtracting the female promoteds. That's kind of how I write it. So I would subtract 20 out of 200. So I almost always, when I do these problems, I write them out first, female plus promoted minus female promoted, because that kind of gives me a visual of what I'm looking at. And then when I put the math together, I get 110 out of 200, which is 55%. What's the probability of selecting a police officer who is male or not promoted? So we have male plus not promoted, and then we're going to subtract the male not promoted. So here's my males, 120 out of 200, plus the not promoteds, 150 out of 200. Here's my overlap, my male not promoteds, so I'm going to subtract 90 over 200, which gives me ultimately 180 over 200, which is 90%. So you have a 90% chance of finding an officer who is male or not promoted. Conditional probabilities. This is when we use the word if or the word given. So, given that the officer is female, if the person is male, what does that mean? It changes the total of what you're talking about. So, let's look at some of these. Still dealing with the same table. If a police officer is a woman, okay, so that's the key word if. If it's a woman, that means we are only concerned about the females. That means my denominator is going to be 80 because I only care about the female police officers. So if the police officer is a woman, what is probability she was promoted? Well, looking at just my females, here's my promoteds, and I'm 20 out of 80, 0.25, 25%. So if you have multiple colors of pens or highlighters, it might be good to go ahead and highlight these things of what you're looking at. In number 10, if the police officer was promoted, boom, here's what I'm talking about. Look at my denominator. My denominator is 50 because that's the total. Probability was a woman. Here's my women in that spot, 20 out of 50, 0.4, 40%. In number 11, if the police officer was promoted, again, denominator of 50, what's the probability the officer was a man? 30. 0.6, 60%. Notice, in 10 and 11, we both talked about if they were promoted. Well, if they're promoted, you have two options, male or female. So together, 40 plus 60 gave us that 100%. Those would be complements. What is the probability the officer was a man if he was promoted? So again, follow the word if. If he was promoted, that's where you find your total, and then we're looking at a man. And you might say, Becky, we just did that problem, and you're right, we did. But the wording in the problem is a little bit different, and I want to make sure that you have the wording down. You're looking for the key word, if, or given. Either one of those could be used. But whatever follows that, that's what's going to be in your denominator. That shows your total. And number 13, how can conditional probability be used to identify whether this police department is gender biased in giving promotions. Because when you first look at this raw data, you might say more males are being promoted than females, and that's bias. They're showing favoritism to males. Well, are they really? So the way we can check this out is we can do two conditionals. If you're a woman, what's the probability of being promoted? And we can say, if you're a man, what's your probability of being promoted? Okay, so we can look at them based off your gender. So first with women, if you're a woman, we're looking at these. Probability of being promoted. That's 20 out of 80. That's 25%. So if you're a woman, you've got a 25% chance of being promoted. Okay, now let's look at men. If you're a man, probability of being promoted. 30 out of 120, 0.25, 25% chance. If you're a man, you also have a 25% chance of being promoted. So you can't necessarily look at raw numbers because it depends on the total. Here you can see our totals are different. Because the totals are different, that's going to create differences in the promoted. We have more men total, so it makes sense that more men would be promoted. So sometimes you got to look at proportions or probabilities in order to really be able to compare accurately.